Hi everyone, today we're going to go ahead and start notes for chapter 5.1, inverse functions and inverse relations. The first thing I want to say is that I miss all of you terribly, and I wish we could be doing this in class right now, but I know we're all doing the best we can in this crazy time. The second thing is that before you get started, you need to make sure that either you have printed these notes out if you have a printer and you're following along and filling them out, or if you don't have a printer, then you need to make sure you have a blank sheet of paper and a pencil and at least getting the minimum of these notes down. You need to be taking notes during this time so that you can make a note card for your test. So going ahead to getting started. The first definition we have here is inverse relation. An inverse relation is changing the first and second coordinates of each ordered pair in a relation produces the inverse relation. Inverses have some pretty special properties that we're going to talk about at the end of probably the second video. But for now, we're going to start with inverse relations and showing you how to find them. So before we get started on that, inverses have some special notation that we need to talk about. If you have f of x, the inverse of f of x is written like this, f to the negative 1 power of x. Okay, this is said the inverse of f, or you could say f of x, either way. Again, this does not mean that you are a negative 1 power. You're not taking the entire function and flipping it or making it a rational function, because that's normally what the negative 1 exponent does. Since it's in function notation, that negative 1 just tells you that it's the inverse. This, all it does, it says this denotes the inverse. So let's go ahead and get started. It says, number 1 says, consider the relation of f given by these sets of ordered pairs. Find the inverse of the relation. All you do is, it says up here, interchanging the first and second coordinates. All you're going to do is flip the x's and y's. So you take this ordered pair 2, 4, flip it. That gives you the inverse of that ordered pair. Take the ordered pair negative 1, 3, flip it. That gives you the ordered pair of the inverse. So the inverse of f is written like this, f inverse of x equals, now I want to use my curly braces because it's a set of ordered pairs. So the inverse of 2, 4 is 4, 2. All I did was flip my x's and y's. Comma, the inverse of negative 1, 3 is 3, negative 1. Again, flip your x's and y's, bringing your signs with it. Comma, the inverse of negative 2, 0 is 0, negative 2. And then you close your curly braces here. That's the inverse. That's literally it. So I'm going to do one more example, and then you're going to try one on your own. Consider the relation f given by these sets of ordered pairs. Find the inverse of the relation. Here, f inverse of x is equal to the set of ordered pairs with x's and y's flipped. So I'm going to flip the first one, giving you negative 5, negative 1, flip the second one, negative 3, 0, flip the third one, 1, 2. And make sure you close your curly brace. There's my inverse relation. That's it. So your turn. Here's a last one. I want you to try this on your own. There's going to be a question that pops up for you to pick an ordered pair sets of answers, and then you're going to compare it to the correct answer right now. All right, hopefully you have gotten that one right. Moving on to the horizontal line test. So the horizontal line test I'm sure you've heard of the vertical line test from Algebra 1. Remember, the vertical line test tells you if what you're looking at is a function. Now, the horizontal line test tells you whether the function is one-to-one. So the thing you're looking at is one-to-one. And then it tells you if the inverse of what you're looking at is a function. So when you're looking at this, the inverse will flip over a line y equals x, which we'll talk about a little later. And it's just doing the horizontal line test tells you whether the new function, the inverse, will be a function or not. The first thing you do is draw a horizontal line anywhere on the graph. If the line touches the graph only one time, it passes. If the line touches it more than once in any point, then it fails. If f of x passes the horizontal line test, then the function f of x is one-to-one, and the inverse is a function. So this is just f of x. If f of x fails the horizontal line test, then f of x is not one-to-one, and f inverse is not a function. So being one-to-one and the inverse being a function, and not being one-to-one and the inverse not a function, that's directly correlated. From the graph shown in each, determine whether the function is one-to-one and thus has an inverse that is a function. So if I look at letter A, if I draw a horizontal line anywhere on this graph, the horizontal line is going to cross f of x only one time. That tells me that it passes the horizontal line test. So this tells me that the first thing is that it passes the horizontal line test, which I'll just say HLT. Since it passes the horizontal line test, it tells us these things. That tells me that f of x is one-to-one. And it also tells me that the inverse, f inverse of x, is a function. We need to know these things so that when we actually find the inverse of the function, that we need to know when to find the inverse of the function. You only find the inverse of a function if the function is one-to-one or the inverse is a function. We don't want to find it if it's not a function for now. So looking at letter B, if I draw this horizontal line, I'm going to choose right here. This one, letter B, fails the horizontal line test because it crosses the graph at two different places. Now, I want to point out that if you tried it on the x-axis right here, it seems like it would pass because it only crossed one spot, but it needs to be anywhere that you draw the line, it has to pass. So right here, this tells me that it fails the horizontal line test. That tells me that f of x is not one-to-one. So that then tells me that the inverse is not a function. And that would tell me that I am not going to go through the work of finding the equation of the inverse in the next couple of examples that we're going to do after this. But that's the important part for now. Let's looking at letter C. Okay, it gives us an equation here. We are going to use the horizontal line test again. Now in this one, anywhere that I draw that horizontal line, it will touch the graph exactly only one time. So this tells me again that it passes the horizontal line test. Since it passes the horizontal line test, that tells you that f of x is one-to-one. And it tells you that f inverse of x is a function. All right, your turn. Go ahead and do D on your own and see if you can get the correct answer. This is the end of the first video of notes, and I'm going to do the second video for the second half of the notes.